Hello, I'm Jason with ScienceandMath.com, and today we're going to talk about prime factorization of numbers. It's a topic that you'll be asked to conquer. It's an easy topic to master, and I'm going to show you step by step how to do that now. Now, first remember from a couple of sections ago, we talked about factoring. We talked about factoring numbers. And just remember that a factor is just a number that can be divided into whatever number I'm referring to. That's all a factor is. Another way of looking at that is seeing that any two numbers that can multiply together and give you that other number, they're both factors. So what we're going to do is use that idea to build what we call a factor tree to find these prime factors, and I'll explain what a prime factor is along the way. The easiest way to move forward is by an example. So what we're going to have, let's just take an example. Let's say we have the number 24. And you're not just asked to find the factors of 24. We've done that in the previous section. What you're asked to do here is figure out what are the prime factors. What are the prime factors of 24? So anytime you see that you're asked to find the prime factors of anything, then you do what we call a factor tree. And between you and me, I actually love building factor trees. They're actually fun for me. So let me show you how to do that, and you'll see that yourself. All you do is think of any two numbers at all, that will multiply to give 24. So there's lots of different ways to proceed. So in this case, let's just say that I pick 8 times 3. So I'm going to put a little dot here because it's 8 times 3. If you remember from multiplication tables, 8 times 3 is equal to 24. Okay, so this is building our factor tree. So we're going to build a tree down here. Now the next thing you do is you look at 8. So there are a couple of choices, but let me just go with 2 times 4, because 2 times 4 give me 8. All right, now let's look at the 4 down here. Do I have any two numbers that can multiply together to give me 4? And of course I do. I have 2 times 2. 2 times 2 gives me 4. Now what we have is we've built a factor tree, and at the very bottom of this tree is what we're interested in. You could look here and you could ask yourself, what multiplies together to give me 2? But the only thing that can multiply together to give you 2 is 1 times 2. There's nothing else that can really work. In other words, the number 2 is so simple and so small that there's nothing really that can multiply together to give me 2 except for the number 1 times the number 2. So we're done at that point. You don't keep building the tree once you get down to that point. Also, here's a 2 and here's a 2. Notice the other guy we have at the bottom of this leg of the tree is a 3. The only two numbers that can multiply together to give you 3 is 1 times 3. And there's nothing else that'll work. So you build your factor tree going down every branch, continuing to write down what multiplies together, okay, until you get to the point where you get down to these low numbers that you just can't keep finding new factors for other than the number 1 and the number itself. So we say this factor tree is complete. And so what we want to do is write down the answer. And so since we were trying to find the prime factors of this guy, what we found is the prime factors of the number 24 is 2, 2, 2, 3. So what you do is you list everything at the bottom of the tree. 2, 2, 2, and 3. See, this tree has gone and done its thing, and we're done with it. So every number at the bottom of the tree and every branch is what we write down. So what we're saying here is that these are prime factors. Now, let me explain. I've kind of danced around it. Let me explain. Recall, you should have learned this in the past, a prime number. It can only be divided by itself and the number 1. So the numbers that are prime are numbers that are special because they can't be divided by anything except for themselves and the number 1. So the number 2 is prime because you can't divide it by anything but the number 2 and the number 1. Number 3 is prime because you can't divide it by anything but the number 3 and the number 1. Number 5 is prime. Number 7 is prime. Things like 6 are not prime because you can divide 6 by other things. You can divide 6 by 3 and you can divide 6 by 2. But things like number 17, that's prime because you can't divide it by anything other than itself, 17, and the number 1. So when we say we're doing prime factors, we're just trying to find the factors of the number that are prime. That's all we're doing. And the way you do that is by building this factor tree, because every branch of the tree is done and everything at the bottom is basically a prime number. So another way of writing the answer, if you're listing the prime factors, you just list them out with commas like this. All right. Sometimes you might be asked to write down the prime factorization. The prime factorization. And the way you write that is the number we originally were talking about was 24, right? And so you just go to the bottom of the tree. It's 2 times 2 times 2 times 3. Now if you remember a factor is something that can be divided into a number. Another way of looking at it is if you have two factors of something, they're just things that you multiply together and they can give you the original number. But since we've gotten this tree down so simple, everything at the bottom, if you were to multiply it together, will give you 24. 2 times 2 will give you 4, times 2 is 8, times 3 is 24. So prime factorization is just taking your number, busting it down into the simplest prime numbers that you can that will multiply together to give you the number that you're asking for. All right? Now let me show you really quickly before I move on to the next problem that here is 24. There's multiple ways that you can proceed with the number 24. See, in this case, we chose 8 times 3 that will give me 24, but let's just say that I chose something different. Let's say that when I was looking at this problem, I chose 6 times 4 to give me 24, because that's equally valid, right? So then I would go in this leg of the tree and I would say, well, what times what will give me 6? So 2 times 3 will give me 6. I can't continue any more here because 2 is prime and 3 is prime. There's nothing else that I can figure out that can multiply together to give me those numbers other than the numbers themselves with 1. But over here I have the number 4, which can be factored out into the prime factors 2 times 2. So notice what I have here. Even when I start and choose a different set of starting numbers, I'm always going to end up with the same numbers at the bottom. 2, 2, 2, and 3 are exactly the same numbers as 2 times 2 times 2 times 3. So the factors that you get if you've done it properly, it's not going to matter the exact thing you choose. As long as you do everything correctly, you read everything off of the bottom of this tree, and you're going to be in good shape. All right, so let's do another problem, maybe a little simpler problem, backtrack a little bit. Let's look at the number 21, and we want to find the prime factorization, or the prime factors of 21. So what you do is you say, what times what will give me 21? And I'm thinking, and I'm coming up with 7 times 3 is 21. Okay, so then we look at the number 7, and we say, what times what will give us 7? And then you realize that the only thing that can really multiply together to give you 7 is 1 times 7. There's nothing else, so 7 is prime. And the same thing with the number 3. You can't go any further there, so it's prime also. So there's actually nothing else to do here, even though this is a really simple tree. So if you wanted to write down the prime factors of the number 21, all you would do is say 7, 3. That's all you would write down. And if you wanted to write the prime factorization of the number 21, then what you would do is you would say like 21 is equal to 7 times 3. Or 3 times 7, however you want to write it down. Basically whatever's in the bottom of the tree. Now this obviously looks simple because we know that 7 times 3 is 21, but these are both prime numbers and that's why it works out that way. All right, so let's move along and say we want to work on the number 16. And we want to find the prime factorization of the number 16. Okay, so the first thing we want to do is figure out what times what will give us 16. So let's just pick the first thing that comes to mind, 4 times 4. I know that that's equal to 16. And I know that I can bust up the number 4 very easily to 2 times 2, and I can bust this 4 into 2 times 2. All right, so the number 2 is prime. There's nothing else that you can find that's going to multiply together to give you the number 2 other than 2 times 1. So the tree is done. There's nothing else to do anywhere, so all we have is a bunch of 2's at the bottom. And so the way you write that down is you say the prime factors prime factors are 2, 2, 2, 2. Now you need to write down the multiplicity. You need to write down as many 2's as you find in the bottom there to list everything. And the prime factorization the way you would write that is 16 is equal to 2 times 2 times 2 times 2. So when you write the factorization, you're writing them down as they're multiplied together. When you multiply these things together, it does give you 16. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So everything at the bottom of this tree, that's what the tree is doing. Every time you get the stuff at the bottom, the numbers at the bottom, they are all going to multiply together to give you the number that you're after. All right, for the final problem here, just to kind of give you a little more practice, what if we had the number 40, 40? Okay, how would we find the prime factors of that? Well, we just bust it up. I'll just come up with the first thing that comes to mind. 10 times 4 is 40. And then I look at the number 10, and I know I can do 2 times 5 is 10. The number 2 is prime. I can't really come up with anything else to multiply together. The number 5 is prime. 1 times 5 is the only thing that'll work, so that's done. And then for 4, we know we can do 2 times 2, and we've already said that 2 is prime. So this is as simple as I can get. I can't really do much more than that. So the factors, the prime factors, simply are going to be a listing here. 2, 2, 2, 5. You list all the extra numbers that you have, and then the prime factorization of the number 40 is 2 times 2 times 2 times 5. So you list them all multiplied out together. And that is the end of the road with what we call prime factorization. It's a skill that comes up a lot, mostly because in fractions we're constantly finding factors so that we can simplify these fractions and so that we can find common denominators and do things like that. So the easiest way to find prime factors, if you're ever asked to find a prime factor, is to do this factor tree. So literally you can choose anything you want that'll multiply together to give your number, and you keep breaking it down as you go down that tree until you're finally to the simplest numbers that you can have at the bottom, which means they're going to be prime numbers. And once you get to that point at the bottom, then those numbers at the bottom, you list them, those are the prime factors, and when you multiply all of them together, they're called the prime factorization. In this case, 2 times 2 is 4. 4 times 2 is 8, 8 times 5 is 40. So if you do your prime tree correctly, everything at the bottom multiplied together is going to give you the number that you were given in your problem to begin with.